practical example requiring calculation of conversion angle. Firstly, determine the value of convergency between J, which is at 58:12 north and 4 degrees west, and K at 58:12 north and 6 degrees east. Then, what is the run line track from J to K? Finally, what is the initial great circle track from K to J? As always, try to visualize the situation. Draw a diagram. Either of these will do. Let's solve the first question first. What are you going to do? Write down the convergency formula and substitute in what you know. Convergency equals the change of longitude times the sine of the mean latitude. The change of longitude is from 4 west to 6 east. That's 10 degrees. Now we need to calculate the sine of 58 degrees and 12 minutes. This may be the first time you've had to deal with a trigonometrical function involving both degrees and minutes, as opposed to decimal degrees, so we'll take a moment to deal with this. You could simply realize that 6 minutes of arc is 1/10 of a degree, just as 6 minutes of time is 1/10 of an hour, in which case 12 minutes is 0.2 of a degree. You can then just key in 58.2 degrees into your calculator. However, most scientific calculators have a DMS key. It stands for degrees, minutes, seconds. Different models work in different ways, but in general, you key in the degrees, press the DMS button, then key in the minutes, and press the DMS button again. We don't normally need the seconds. Find out how yours works and it will save you time. But however you do it, don't treat 58 degrees and 12 minutes as 58.12 degrees. It's a common mistake. Going back to our example calculation, the sine of 58 degrees 12 minutes is very close to 0.85. So the convergency is 8.5 degrees. That's the first part of the problem solved. Now let's look at the second part. What is the run line track from J to K? J and K are both at the same latitude. So what will the run line track from J to K be? Clearly, the answer is 090 degrees true. This is a parallel of latitude. So that's the second part answered. Now the third part. What is the initial great circle track from K to J? Think about how you will approach this problem, remembering that this lesson is on conversion angle. What will be your method? You should have appreciated that we know what the run line track from K to J is, so all we have to do is to apply conversion angle to it. What is the run line track from K to J? Well, from our previous work, we saw that the run line track from J to K was 090. Since K to J is just its reciprocal, then the run line track from K to J must be 270 degrees true. It's still the parallel of latitude, but in the reciprocal direction. We now need to work out the conversion angle. What is it? It will be half the convergency, of course. We already worked out the convergency in the first part of the question. It was 8.5 degrees. So the conversion angle will be 4.25 degrees. What does this make the initial great circle track from K to J? .274.25 degrees true. Now you try one. Given that A is at 55 north, 0 east-west, and B is at 54 north, 010 degrees east, if the initial great circle track from A to B is 100 degrees true, what is the true rumline track at A? What's the first thing to do? Draw a diagram, of course. So do that now, and only when you've drawn it, click to move on. It should look like one of these. So now find the conversion angle. The change of longitude is 10 degrees, and the sine of 54.5 degrees is almost exactly 0.8. So you should have found a conversion angle of 4 degrees. So what does that give you as a rumline track? The rumline track is 104 true. Now, a more practical example. Look at this question. The following waypoints are entered into an inertial navigation system. Waypoint 1 is 5308 north and 30 west. Waypoint 2 is 5308 north and 20 west. Waypoint 3 is 5308 north and 10 west. The inertial navigation system is connected to the automatic pilot on the route waypoint 1 to waypoint 2 to waypoint 3. What will be the approximate track change on passing waypoint 2? Firstly, let's envisage the situation. We have 3 meridians at 10-degree intervals. The 3 waypoints are all at latitude 5308 north, which, as a parallel of latitude, forms a rumline. However, you should remember from your instrument studies that INS steers the aircraft on a great circle track. It takes the aircraft from waypoint 1 to waypoint 2, and then from waypoint 2 to waypoint 3. This produces a significant track change at waypoint 2. It might be easier to see it in this diagram. The left-hand one shows the great circle as the shortest route, but the right-hand one makes the track changes more obvious. The track leaves waypoint 1 on an angle of less than 090 and gradually increases, arriving at waypoint 2 on an angle of more than 090. At the waypoint changeover, the track decreases significantly in a single step to an angle of less than 090, and then gradually increases again, arriving at waypoint 3 on an angle of more than 090. The waypoint 2 changeover is this angle, or, if you prefer it, this angle. We need to find out what it is. How are we going to do that? You should realize that the rumline track is 090 everywhere, but that the great circle track will be greater than 090 by the amount of conversion angle here, and less than 090 by the amount of conversion angle here. If we can calculate the amount of conversion angle as we enter and leave waypoint 2, adding them together will give us the amount of track change at the waypoint changeover. Fortunately, they are both the same angle. The change of longitude on both legs is 10 degrees, and the mean latitude on each leg is 5308 north. This gives us a conversion angle of 4 degrees in each case. So what is the great circle track angle immediately before the waypoint changeover? You should have answered 094. And what is the great circle track angle immediately after the waypoint changeover. It's 086. So at the waypoint changeover, there is an instantaneous track reduction of 8 degrees. Let's summarize what we've covered in this session. Convergency is the change in a great circle track. It does not involve the run line. Conversion angle is the difference between great circle direction and run line direction joining 2 points. Conversion angle is half convergency. Conversion angle is half the change of longitude times the sine of the mean latitude.